Okay, today we are going to talk about vertex form of quadratic functions. So there's two forms we have currently. The first form we've talked about before, it is standard. Y equals ax squared plus bx plus c. So what you can get from the standard form is you can actually get the y-intercept from your c. So it's going to be 0, comma, whatever c is. And you can also get your opening direction, that's A. So we talked about that in the last lesson. So A will tell you which direction it opens. Opening direction. If A is negative, that means it's going to open downward, so that vertex is going to be a maximum. If you have a positive A, your vertex is going to be a minimum and it opens upward. The new form we're going to talk about is this vertex form over here. So before, when you were trying to find vertex from the standard form, you had to first find the axis of symmetry, take that number, substitute it in to find your y. Well, vertex form actually helps us find the vertex a lot faster. So first thing I see is, well, I still see that it has an A value. Well, that still tells you opening direction. A will always tell you what direction it opens. Okay, now we said way back in our earlier notes that H and K was your vertex. So vertex, we said, was H comma K because it is a special point. So H comes from inside with your X inside that square. Now it's always opposite though. So if you see that it has a negative H, that means your point is actually positive. So the H tells you the X value. And this K, that's always the same. K's sign does not change. This guy tells you your Y value. And that's about all we can get from vertex form. We can't get the y-intercept from vertex form. You have to do some work for the y-intercept. So let's do an example with this. So here are my general steps for each item, for each attribute. So the first thing we have is the vertex. Find your H from your equation and your K, and we're going to plug them in. So let's do the vertex for this example number 1. So what is the vertex? Axis of symmetry, y-intercept, and opening direction for the function y equals 2/3 x plus 6 squared minus 4. First thing we're going to do is find the vertex. That's what it tells us to find first. So vertex is always h comma k. Right? Now, the h comes from this inside piece right here. So this is usually your h. Now, if you notice in the equation part up top, it actually has x minus h. So if it's x minus h, but I have a plus 6 right here, what that really means is that h is actually equal to a negative 6. This is always opposite from the sign inside the equation. Then we get k from this outside number. Now k is always the same, so since it says minus 4, that means k is equal to a negative 4. So we're going to set up our vertex using these two pieces. So it's usually h comma k, so that means our vertex is going to be negative 6 comma negative 4. A lot faster than trying to find it from standard form. That's why this is called vertex form. You can find the vertex very quickly. The next thing it asks us to find is the axis of symmetry. So luckily the axis of symmetry and the vertex are related. So for the axis of symmetry, what we're going to do is we're going to just say x equals and then whatever h is, because it's the vertical line that runs through your vertex. So h on our vertex, let's put number 2 for axis of symmetry. H on your vertex was negative 6. So if this is x equals h, and I know that h is equal to negative 6, what that means is your axis of symmetry is x equals negative 6. Next thing it asks us to find is the y-intercept. So finding a y-intercept will never change. For the y-intercept, you always know that your x is equal to 0. That's just how a y-intercept is defined. So what we're going to do is we're going to replace x with 0 and then simplify to find the y value. So I've got 2/3 times x is now 0 plus 6 squared minus 4. So y equals 2/3. 0 plus 6 makes 6. One step at a time. 6 squared is 36 minus 4. So now I have to do 2/3 times 36. So remember, this is over 1. So when you multiply fractions, I can do either the multiply first or I can do the division part first. So I'm going to actually do divide first. So 36 divided by 3, that's equal to 12. And then 12 times 2 makes 24. So y is equal to 24 minus 4. So y is equal to 20. So your y-intercept then is 0, 20. Last but not least is we're going to find the opening direction. So this is the same as it was before. If your A is positive, it opens upwards. If your A is negative, it opens down. So let's look at our equation. So for step 4, we're going to find the opening direction. All right, so in this case, our A is positive. Remember, it doesn't really matter about the number itself. So since A is positive, it's going to open up. So it's going to look like this. So we can find all attributes either from standard form or we can find them from vertex form. It just depends on how you're given the equation. Let's try one more. So for number 2, determine the vertex, axis of symmetry, y-intercept, and the opening direction of the parabola represented by y equals negative 3 x minus 4 squared plus 8. So remember that the word parabola, that's just the shape of my quadratic function. That just tells me that it's that U shape. It tells me that it's a quadratic. So let's go through our steps one more time. So find the vertex first. So our vertex is h comma k. Vertex is h comma k. And we get the h and the k from your equation. H is the one inside the parentheses, k is the one on the outside. Since the h is inside, it's actually backwards from the sign. So since this says a minus 4, your h is actually positive 4. K is the one that stays the same. That one's not going to change. So since it says plus 8 here, that means your k is an 8. So put this in a coordinate point, 4, 8. That is the vertex for this parabola. No math involved. Vertex form makes it very easy to find the vertex. Next thing we're going to find is the axis of symmetry, the AOS. That is always x equals and then whatever h is. So since h is a 4, that means that our axis of symmetry is x equals 4. Next, we're going to find the y-intercept. So for a y-intercept, the x value is always equal to 0. So we're going to take 0 and substitute it where x is. Y equals negative 3 times 0 minus 4 squared plus 8. Negative 3, 0 minus 4 makes a negative 4 squared plus 8. Squaring has to come before multiplying, so negative 4 squared makes a positive 16. Now I can multiply, so negative 3 times 16 equals negative 48 plus 8. Negative 48 plus 8 equals negative 40. So my y-intercept is 0, negative 40. Last thing that we can determine from the vertex form equation is what direction our parabola is going to open. So opening direction. Okay, so now we gotta look at our a value. So in this case, our a value is actually a negative 3. Again, the number is not really what matters. It's the fact that it's negative. So that means our parabola will open down. So the vertex is going to be a maximum this time. Okay. Last example is number 3. So again, determine the vertex, axis symmetry, y-intercept, and opening direction of this parabola. So step 1, find your vertex, h, k. h comma k. H is the number inside the parentheses, k is the number outside the parentheses. H is the one that is always backwards. So since this says plus 3, that really means your h is a negative 3. K is the one that makes sense. K is the one that doesn't ever change. So since this says plus 9, that means k is a positive 9. So when you write your coordinate point, you're going to have negative 3 comma 9 as your vertex. With the vertex, you can also find the axis of symmetry. Okay, that's always x equals h. So the axis of symmetry in this case is going to be x equals negative 3 because that's the h value of my vertex. Third thing we're asked to find is the y-intercept. So the y-intercept always has x being equal to 0. So substitute a 0 where x is and then simplify down. So 0 plus 3 makes 3 squared plus 9. 3 squared makes 9. So 9 plus 9. And 9 plus 9 is equal to 18. So my y-intercept is at 0, 18. Lastly, find the opening direction. Okay, that's looking at your a value. Now, what is the a value? There's nothing in the front. So the a value here, remember, there's always something multiplied that nobody ever really writes. So if there's no, that doesn't look like there's an a value, remember that there's a 1 in the front that is always multiplied. So in this case, the a value is a 1. Well, it's still positive, so that means it opens upward. Okay? Now, the next part of this is we need to figure out, well, how do I go from vertex form to standard form? Sometimes standard form is more helpful. It just depends on what you're being asked for. So we're going to convert the vertex form equation into the standard form equation. So they're both the exact same parabola, it's just written two different ways. Kind of like you can write linear functions in standard form, slope-intercept form, or that point-slope form. They all mean the same, just one is a different way of writing it. So when you try to change vertex form to standard form, you're really just expanding stuff out. So you can kind of think about this as expanding the equation. So what that means is we're going to take the square and actually write it out twice, because it means when you square something, you're actually saying to multiply that thing times itself. That's what being squared is. So now that I've expanded, we're just going to perform order of operations and simplify this down as far as we can. So according to order of operations, we have to multiply first. Well, these two are the things being multiplied. How do you multiply something that has two terms times two terms? That's your double distribution. So we're going to do x times x, which makes x squared. Then we're going to do x times negative 3, which makes negative 3x. Now we're going to do negative 3 times x, which makes another negative 3x. Negative 3 times negative 3 makes positive 9. Keep all of this in parentheses, and then we're going to have plus 2. And then a y equals hanging out on the side. Now, this is still in parentheses just in case we have some more multiplication to do. But I don't have anything else multiplied to this. All we have is something added. So these parentheses we really don't need anymore. So let's try to combine some like terms together. I've got negative 3x and negative 3x that are like terms. So that makes negative 6x plus 9 plus 2. Now the other set of like terms that I have is 9 and 2. X squared plus 6x, 9 plus 2 makes 11. So this is the standard form parabola that goes with the vertex form from up here. These are the same equations, just written in two different ways. Let's try another one. Write the quadratic function y equals negative 5 x plus 4 squared minus 2 in standard form. First things first is we have to expand this guy out because exponents come before multiplication. So we're going to have y equals negative 5 x plus 4 times itself, because that's what being squared means. And now we're going to simplify. Multiply any way you wish. I'm going to multiply these guys first and hang on to the 5 for a minute. So x times x makes x squared. X times 4 makes 4x. 4 times x makes 4x. And then 4 times 4 makes 16. Now remember, all of this stays in parentheses, and the reason why is I still have to multiply this negative 5 in the front. The first example we didn't have another set of multiplication. This one does. So I can't mess with this minus 2 just yet. I have to finish multiplying first. But before we do that, let's first combine some like terms to make a little bit smaller multiplication. So we're going to have y equals negative 5 times x squared. 4x plus 4x makes 8x plus 16, and then minus 2 on the outside. Now that I've cleaned up the blue part, I'm going to distribute in this negative 5. Negative 5 times x squared makes negative 5x squared. Negative 5 times 8x makes negative 40x. Negative 5 times 16 makes negative 80. And then drop your minus 2. Now that all the multiplication is complete, you can actually combine your like terms together. So y equals negative 5x squared minus 40x minus 82. So this is the standard form equation that goes with this vertex form equation. Again, these are the same parabolas, just written 2 different ways. Sometimes standard form may be more useful than vertex form, just depending on what the question is asking.